Okay, good morning everyone. Hope you all are doing good today. We'll get started from where we left yesterday. So yesterday we were talking about big data and we were talking about some of the analogies that we were uh, trying to relate it with big data concepts. Also, we discussed about the distributed computing and how MapReduce and GFS were introduced and how we are going to compute if there is if a file size is greater than your size of the RAM. So today we are going to start about some of the fundamentals of the data engineering, I would call. So these are some of the things that we are going to discuss today. So we are going to talk about the compute memory, storage, then data caching, um, throughput, latency, then network bandwidth. Okay. Then we are going to touch base on structured, unstructured, and semi-structured data. And if time permits, if there are less questions or if time permits, then we are also going to talk about data sources like APIs, flat files, tables, or streams. Also, we are going to talk about pipelines and orchestration. So these are going to be our topics for today. I'll try to complete all of them. In case if the time is not I mean if we don't have enough time, then we will try to cover data sources tomorrow. Okay. This is going to be our agenda for today. Let's get started with compute. Could someone please help me understand what a compute will be, or if anyone is already aware of compute, maybe they can give me a quick short answer about what a compute is.
You did anything combination of your computer resources,
Yes,
including all memory, disk, RAM, CPU, and all the stuff.
yes, that's correct. So it is nothing but a processor, right? So a compute is nothing but a processor that is going to run your programming logic, and it is going to have like you mentioned, it is going to have a CPU, RAM, and storage, then networking, uh, right? So compute is nothing but a processor, guys. It contains either a single CPU or multiple CPU, multiple cores, or single cores within that CPU. So when you have multiple cores, you can actually work on each core for a particular task. So if you have, let's say, three cores or four cores, you can give a single task to each of these cores. So your tasks are going to be run in parallel, right? Then we talked about RAM yesterday as well, which is fast and volatile. So this is going to help you with high speed data processing. Um, right, then storage, we are going to touch base on storage today and networking today. So this is in short about compute. Now within compute, we have some types. So we have a compute type called virtual machine. If you have heard about it, then we have a serverless compute. So this is the latest feature added by Databricks, guys. We'll talk about serverless compute in a bit. We also have, this is rare, but this also exists, which is known as GPU compute. Okay, so this is specifically related to AI and ML in models. Okay, generally, if the compute that will be used is a GPU compute for AI and ML models. Virtual machines, we all know that it's a virtual computer almost, right? So all of these elements are going to be present virtually, right? So it's simple as a virtual computer. What this gives you is it gives you full control, guys, full control over your OS, your apps, your updates, right? So it is going to give you every single opportunity to control your apps, OS. If you want to control your softwares, you can do it. So this is about virtual machine. It's like, buying a unfurnished flat or an apartment. You just get the walls and you are going to decide how to design your apartment. It's like that. Serverless compute, it's like you don't get to manage server. That means server is given by someone else and you are just going to use it. Okay, so it is readily available, it is directly usable. You need not build anything. Right? Now, unlike virtual computer where you have to decide what OS you want, what apps you want, what softwares you want, serverless compute is like virtual computers are already up and running. So whosoever is providing this serverless compute, like for example, Databricks, what they'll do is they will already have some virtual machines running in the background. Okay, so they are going to allocate those virtual machines to you. So what this helps is it is going to be fast because already the virtual machine is already started in the background and it is just being assigned to your job as in your task, whatever task you want to do on this compute. The serverless compute is going to give you a fast startup time. It is not going to take much time because the backend part is controlled by someone else who is providing this serverless compute, right? So this is advantage of using serverless compute. The disadvantage is it is expensive because there is no control and somebody else it is already running in the background, right? It is going to give you a quick start time and even if you terminate this serverless compute and restart it, the reboot time is also fast. Okay. So that is the advantage of serverless compute. It is fast and disadvantage is it is expensive, right? GPU compute, we discussed that it is for AI and ML models. It is the most expensive compute out of all these three. Unless until you have a requirement of AI and ML, we shouldn't consider GPU compute at all. Okay, all right. Then we'll get started with memory. So memory is nothing but RAM in short. So we already discussed that RAM is volatile, which means if there is a shutdown of a computer, you are going to lose everything that is present in RAM. Okay. Most probably we use RAM to hold the active data. Active data means anything that you are working currently, right? So the difference or in short, what we can say is RAM is responsible to hold the size of the data that is being processed, guys. Right? So this actually is responsible or this actually is going to affect the size of the data that is being processed. Okay. If you look at processor is going to affect the speed of data. We'll talk about this analogy in a bit, like how these two are going to be related in data engineering space. Uh, right? So RAM is going to affect the size of the data, processor is going to affect the speed of the data. Okay. So the other thing that we want to talk about is if you look at RAM and processor, and if you think about, let's say you have a data set of a CSV or a Excel file that you want to process, and if you look at the processor and RAM here in this processing of this file, we need to think about managing this configuration, guys. So if you have a higher RAM and a weak CPU. Weak CPU as in a CPU with less cores. Okay, less cores. So what this does is it is going to process the data faster. It is going to um, process the data faster, but the time is going to get delayed, guys. That means, okay, my bad. Processor is going to get slower because there are number of cores is less, but it is going to take more data, right? Because the RAM is more, so it is going to take more information. More information as in you can read a large file. Let's say if you have a RAM of 16 GB, you can read a file of 10 GB or 8 GB like that, right? So you can read higher amounts of data, but you cannot process it in a quick time because your CPU is less. Similarly, if you have a lower RAM configuration and higher CPU capacity, which means higher cores, CPU cores, then your processing time is faster. That means any operation that you are performing on this data, it is going to be fast because this is more distributed. This is this is having higher core, so it is distributed, right? And because it is lower RAM, the size of the file cannot be more. So what you have to do is you have to create more number of partitions. So in this case, number of file partitions will increase. And in this case, parallelism is going down. So it is always a trade-off between understanding when you have to increase the compute capacity, when you have to increase the memory. This is something that is critical while we are working on Spark and while we are working on big data, because either you are going to see more partitions. We will see this in future classes, but because we are talking about compute and memory, I thought of bringing this. The problem is that either your number of cores is going to be less or your memory is going to be less. And when you are deciding the cluster configuration, when I say cluster, you are going to decide how many virtual computers you want to run a Spark application. Okay. So at that time, you need to ensure that your CPU is not weak or your RAM is not lower, right? You have to decide and understand your big data requirement, how much data you are processing, what transformations you are processing on that big data, and then you have to decide what your RAM should be and what your CPU core should be. This is critical at that point of time to decide and understand the trade-offs. Okay. We are going to discuss deep about this when we are doing the practical hands-on with Spark. But for now, please understand that um, it should never be like you have a higher RAM and less cores or lower RAM and high cores. Okay. These both are going to help us processing big data in much more smoother manner, right? So that's about memory. Um, we can start with storage. Any questions before we move ahead with storage and other concepts? Okay. I'm considering it as a no. So we'll get started with storage. Storage is simple. It's there are types. We have HDD, we have SSD, and we have NVMe. NVMe is also a kind of SSD. It is much more faster than your traditional SSDs. So I think we all already understand that HDD is going to write data mechanically. Mechanically meaning it's a mechanical operation when it is writing the data, and the read or write speed is lower. But if you think about cost, it is cheapest of all these three, right? So the usage, I mean, when should we use HDD? Um, in Azure, we have a storage called Azure Blob Storage, which we are going to cover. Yes, this is as this is in scope. So what we do is, whenever we have processed a file, let's say in Azure storage, let's say we have 10 files and we want to read those 10 files file by file. Okay. So what we are going to do is as soon as we read file one, we'll pick that file one from the storage location and we are going to dump it in Azure Blob Storage. Okay. This is called as archiving of data. Archiving as in we are going to take the file out of the existing storage and we are going to dump it in a cheaper storage. Okay, cheaper storage means a storage that doesn't give you so much of cost. Okay, so that is where we are going to use HDDs. So if you want to archive the already processed file, you are going to go ahead with HDD. Okay, that's a real life example that we are going to see and implement as well as we move forward. SSD is it uses something called flash memory, and it also uses something called SATA interface. SATA interface means something that is going to connect your SSD with motherboard. Okay, the read or write speed is somewhere around 600 MB per second, right? This is expensive when compared to your traditional hard disk. SSD is going to be, if we look at the previous scenario, we were discussing about archiving the already processed file, right? Before archiving, the file is not processed and it is going to stay at some storage location, right? That storage location is nothing but SSD files. So files, the initial storage location of files. So we are going to store the files in SSDs and we are going to process them. Once the files are processed, we are going to dump these files in archive folders. Okay. Uh, then the NVM SSD, it is same. It's non-volatile SSD. So what this is going to do is it is going to just change the interface that we are going to use. This is the fastest out of these three. So this is going to use an interface called PICE. So the read and write speed is around some 6,000 or 7,000 MB per second. Okay, this is the most expensive until unless there is a big requirement of doing a ML or AI processing, the or highest compute power if you need, then only you will have to go with this NVM SSD. This is super expensive. And the advantage is the latency, guys. Latency we are going to talk about in few minutes. For now, just think it as a time between request and response. Okay. So the latency is super slow, which is flexible for real-time processing. So we are also going to touch base on real-time processing. Real-time processing means in simple, you are processing the data as it arrives. If it is coming now, you are going to read that data, apply some transformations, and you are going to load that data as well. Okay. So this is some thing about storage. We are going to touch base on Azure services for storage next week, and then we are going to look at all of these storage types in the Azure itself, and we'll talk about the SSDs and HDDs over there. Okay, we will continue with data caching. So, what do you understand by caching, guys? Can anyone help me? What is caching, and if you know why it is used, you could share that as well.
Generally, caching is storing the data into the memory. Memory means in the RAM.
Yes. So let
So when you have a data in the memory, that is like means like the data reads are fast, and you can access the data fast.
okay, and you are correct. So w- how does it help? Are you aware of why we need to cache and how does it help?
No, only I know is like when you have the data in the memory, like the accessibility of the data is fast than comparing the data in the disk, because like otherwise you have to read from the disk. Always reading data from the disk is slower than the reading from the memory.
Yes, that's correct. Thank you for that. So let's look at this caching. Like you rightly mentioned, it is going to store the um, results of a computed computation task. So we'll go with an example because you have already answered this question. Um, the Let's say I believe you guys understand pandas. So assuming that you understand pandas, let's say we are reading a CSV file. Okay, we have a CSV file and we are going to read it. Then assume that this file is going to have uh, maybe some columns like uh, let's say amount, region, then country. Okay, so these are some of the columns that it has, and let's say it is going to have amount, region is uh, Asia, and country is like India, for example. Then 456, then again Asia, then let's say Russia. Okay, similarly, it is having the data. So it is going to have sales amount for each region and each country. Okay, so you are trying to read this file. And what you are going to do is, let's say, for suppose you want, there is also a region called Europe, okay, and then there is Germany or Italy or something like that, okay. Then there is 789, then there is sorry 67. Okay, so you have multiple regions or we can say continents. And there are multiple countries within that continents, and this is a big MNC, okay, that is having this information. Now you are trying to read that file, you have read the file already, okay. Then what you are going to do is you want to filter the sales amount, you want to perform some aggregation over sales amount, you want to find the total sum of the sales amount for only Asia. Okay, so what you are going to do is you want to filter this data set first to filter out only for Asia, right? So you are going to say df dot filter continent equal to Asia. Okay, I'm not writing the correct syntax, I understand, but this is just for our analysis purpose. I'm going to tell you how catching helps, so that's why I'm writing it like this. So we are trying to filter uh, only for Asia content, right? So what we are going to do is we are going to cache this statement, guys. Okay. So what we are going to do is we are going to say df.cache. Cache is a method that is already available in Spark that lets you store the results of this df.filter. So what happens is we are going to store this df.filter output in another df called filtered df. Okay, filtered data frame. Okay. Um, Data frame is nothing but a table, a SQL table of rows and columns. In case if you don't understand, it is a relational table of rows and columns. Okay. So what we are going to do is we are going to store this df.filter output in a new data frame. And then we are going to apply the cache on top of this. So what it does is the output of filtered the output of df dot filter whatever output you are getting, like in this case it is going to be only this much, right? So all of this information is stored in your memory. Okay, automatically what it does is when you perform a cache, it is going to store all of this information in your RAM. Okay, so this statement is going to store filter df output in RAM. All right. So now what happens is, let's say you want to go deep and you want to use this filter DF to um, see how many records you have, or if you want to do a group by country because you have country, and then you want to find out some totals for each country. Okay, sum of sales amount. Okay, then you can do a display or show, or you can print the output of this statement, right? Group by dot sum. So what you are going to do is you are going to further aggregate this by country, and then you are going to get the sales amount. Now what happens is, because you have already stored the results of this continent specific sales amounts, this count and this group by are going to be much faster because the data is already stored here. It is going to bring that output and then quickly process this count and quickly process this group by, guys. So if you are missing this, if you are not going with this cache, what happens is whenever you do a filter df.count, it is going to be replaced as df dot filter of continent equal to Asia dot count. This is how this statement will be replaced in the backend. Because you haven't cached the results in memory, this is going to be replaced like this. But if you use cache, it is going to be like this. I hope I'm making sense here and you're understanding the difference between caching and not using the cache. Similarly, when you do a group by, this filter df will be replaced in the backend by df dot filter of continent equal to Asia dot group by. Okay, so this is going to trigger additional computation cost because you are again filtering on the data frame that you have read, right? So this is going to put a filter first and then count. Here in the second case, because you have already stored the output of filtered DF in the cache in the RAM, this is going to use the cached data. Whatever data is already present in RAM, it is going to just apply count on that. So the number of operations performed on the on line 33 on this one is lesser than number of operations performed when you do a cache, right? So this is the advantage of doing data caching. Okay, so it is always preferred that you cache the data only when you are going to use it further multiple times. Okay, let's say you are not at all using this filter df and you are doing something else. So there is no point of storing the output of the filter df in the RAM because again it is going to incur some cost, right? So you have to cache the data only when you are going to reuse it multiple times. Okay. If you are not using this Asia filtered specific data frame, you need not cache it because again it will take some memory in the RAM. It will store the results. So that is going to trigger some cost. Okay. Any questions on this example, guys?
Just a quick question. So if you have a very large data set, like I think in the previous class you mentioned like could
Yeah.
be in terabytes. So
Yes.
in that case, if you have that size of data in in RAM, that is also expensive, isn't it? Like, and
Yeah.
then you have to have very large size memory.
Yes, that's a really good question, and thank you for asking. So,
Sure.
if you remember yesterday, we have discussed about distributed processing, right? So, what we are going to do is let's say take that example. You said let's discuss that. Let's say we have a file of 10 GB. Okay, so we discussed yesterday that we are going to distribute this as 2.5 GB per partition per computer per each virtual computer, and we are going to give it a RAM of 4 GB, correct? So what it does is it gives a flexibility to the RAM. If you see the RAM is more, the size of RAM is more than the size of file, right? So what this does is within Spark, I mean, we are going to discuss this in further sessions when we actually deep dive into Spark. So what Spark does is Spark is going to use the same memory as in the allocated memory. Whatever memory is allocated to process these statements, Spark is going to use the same memory to cache the data also. So what it is going to do is, um, within Spark, you have executor memory and cache memory. So both are given, like let's say the memory allocated to Spark is, in this case, it's 4 GB, right? If it is 4 GB, after some allocations, it will come down to 2 GB. Let's take, for example, 4 out of 4 GB, 2 GB is left. Okay. So what this executor and cache memory are going to do is they are going to share this memory dynamically. So if you are going to cache, then out of this 2 GB, the executor memory is going to take maybe 1 GB and cache memory is going to take 1 GB, like that. So depending on the situation, depending on how much caching you are doing, it is going to dynamically adjust the memory at the back end. Okay. And the other perspective is, within big data, when you are processing big data, in case if your cache or if your RAM memory is going beyond this 4 GB, in the worst case, the Spark automatically write that cache data to disk. Okay, so there is an option where if the data exceeds, like you mentioned, right? What if the data is huge and if it could not cache, what it does is it will write that extra data to storage. We discussed about these storages, right? Hard disk and SSDs. So it is going to write that data to SSDs. It is not going to store it in RAM. That is
Oh,
why what develop data engineers has to do is they have to analyze their data, they have to understand their data, and they have to understand what transformations can we do caching and what transformations should we ignore caching, because caching is a expensive operation. So
mhm.
we need to understand which data frame or which filtered logic will be used multiple times, which one we need to cache and which one we shouldn't cache. Otherwise, there is a chance that these cached results are going to get stored in disk because the memory is full. The Spark is automatically going to write this in disk, and anything that is written to disk is going to delay your processing, right? Which is,
Yeah. Mhm.
so we don't recommend going with this operation when the size is huge or when your operations are big, when your transformations are big. It is recommended that you go case by case and you understand which one you want to cache and which one you don't want to cache. Okay.
Got it.
So
Okay.
also, because we are discussing this, when you are done with this, let's say you are done with group by, you found the sum of sales amounts for each, country. Because you are done with this, you have to clear the memory. You cannot store this filtered DF in this RAM forever, right? What we are going to do is we are going to clear the cache. Okay. So, I mean, in Spark, there is unpersist option which is going to clear this intermediate data that we have stored. Okay. So
Okay.
we have to do that as well. Immediately after we are done with our task, we have to clear the data that is present in cache. So Spark dynamically adjusts the memory to process some other task. So this comes under memory management, which we are going to discuss in future sessions. But for the context, it is important that you understand which data to be cached, which data to not to be cached, and then when you have to clear it, when you have to store the intermediate results. Okay, that is a decision that you have to make based on the transformations you are going to do on a particular data frame. Okay.
Okay.
Yeah.
Thank you.
Yeah. And any other questions? This is important concept, but we are going to see the caching as well in the practice when we are going to do this Spark. Okay. So it's just like, if you go to any restaurant or if you go to any coffee shop, what they do is they already have a all-purpose gravy. If you go to some Balaji Santosh Dabas and all, they are going to prepare all-purpose gravy. Irrespective of what you order in the menu, they are going to use that gravy and then they are going to prepare the curry little bit faster, right? They are not going to start from the scratch. They are not going to cut the vegetables. They are not going to cook it in front of us. So similarly in coffee shop, if you think if you go to some coffee day or some big shops like Barista or Starbucks, what they are going to do is they are going to prepare the coffee powder already. Whenever you order a coffee like espresso or latte, they are going to mix those ingredients. They are not going to prepare, they are not going to, grind those coffee beans in front of you. So similarly, caching is like you are just pre-computing the task and storing it as a safety, just to save some time. You don't want to do it again and again. So that's the advantage of caching. The disadvantage is it consumes memory and it is expensive. So we need to be mindful about what transformations should be cached and what transformations shouldn't be cached. Okay, we are going to look at it when we are going to do it in practice. Okay, cool. Then we'll start with throughput, guys. Let me highlight this. So these are headings. Okay. So throughput is nothing but your number of, amount of data that is going to be processed. Okay. So it's like amount of data processed per second. Okay. So generally it is preferred for data engineers to consider a high throughput system. When I say high throughput system, that means the amount of data that is being processed should always be high, guys. So it is an advantage if you have a high throughput, because this is this what this means is if the throughput is high, that means your data movement is fast. Okay, so it's like how much of data is gonna move per second. Okay, and it is like MB per second or GB per second, like that. We are going to see this in live how throughput impacts your data movement. But for now, just understand that in a second, how much of a MB, how much of a GB is being moved from place A to place B. Okay, this is a small concept, but this is important when you are going to do the batch processing. We are going to talk about batch processing in few minutes, but uh, batch processing means you are going to process data in chunks, in some small number of pieces. So whenever you are going to do that, it is important that your data is moving fast. Okay. Um, this will also involve something called network bandwidth. So network bandwidth and throughput are similar. They relate with each other. Network bandwidth means your network capacity. Now network capacity to transfer the data. Transfer the data from place A to place B. So let's say in real time situations, let's say you have a file in your Windows laptop, in your desktop, and you want to move that file to Azure. Okay. So based on your internet speed, right? Based on your internet speed, the file transfer is going to happen. Correct? So irrespective of what your file size is, if your internet bandwidth or network bandwidth is low, it is going to take more time to move that data from your desktop, local desktop to Azure. Correct? So these are some of the basic terms that are going to impact the data movement, guys. The data movement from place A to place B. So in data engineering, when we talk about data engineering, if you remember our diagram that we discussed yesterday, the first step was to collect data from multiple places, right? So when we are collecting data from multiple places, these are some of the terms that we need to be mindful about to look at how much time it is going to take for us to move this data from those multiple sources to Azure, right? So how quickly we can move the data is nothing but throughput. And what is our network speed? What is the internet speed is going to be network bandwidth. So they both are closely related because depending on your network capacity, your throughput is decided. Okay, how much um, we talk about this Wi-Fi broadband things, right? Like Mbps, Gbps. So those Mbps, Gbps are nothing but network bandwidth, guys. So um, Mbps and Gbps. Okay. So this is small concept, but it is important. We will also talk about latency and then we'll try to see how they are related. So latency is the time between request and response. Okay. So let's say you want to move this file from your desktop to Azure, right? So how quickly, when you place a request or when you place this movement of data request, how quickly you are able to get a response is what latency is. Okay, that means how long, or I would say how quickly you got a response from the server, local server. So how quickly it accepted your request, that is your latency. Okay, so it is always preferred to have low latency because uh, low latency means your system, whatever you are trying to do, is more responsive and more faster. Okay, but low latency always comes with cost, so the cost is going to be higher. That is a disadvantage. So um, I mean, if you want an example, maybe we can think about let's say you are ordering any Uber or Ola or maybe a Zomato, Swiggy uh, food from restaurant. Uh, so how much time it is going to take for a delivery guy to come from that restaurant to your place is nothing but a latency, guys. So you have placed an order, but the delivery time, okay, or if you have booked an Uber, how much time it is going to take for that driver to reach your location is nothing but latency.
Yeah, in the computer terminology, maybe if you can say like when you give your username and password, when you submit for the login, then how
Yes.
long it will take for to go to the next page. Suppose if it is taking more than eight seconds, or that's one, like what those all these things will consider in that seconds, the latency. So how short you will get to the next page is called the latency.
Yes, that's a great example, and we can also think about. I mean, if let's say you are trying to reading a CSV file again, considering in data terms, so latency means how quickly um, a read request is processed. Then bandwidth is nothing but how much data can be extracted per second. Okay, and then throughput could be how fast whatever pandas or Spark can process and read this data. Okay, so throughput and latency are always important. They are a trade-off when you are trying to extract the data. Okay, so during extraction means in our data engineering space, we call it as ingestion. So that means you are bringing data from multiple sources. So whenever you are trying to build data from multiple sources, it is important that you understand the latency and throughput. Okay, so you may want to check how much how fast you want this data to be moved. Okay, whenever somebody is a data architect is going to give you a solution that you have to move data from these sources, you have to talk to them and understand how fast you need this data to be moved, right? That comes under throughput. Latency means how frequently the data is being generated and how frequently you want it to be refreshed. Whenever the data movement is happening, how quickly you want to refresh it, right? That's something that you need to check with your data architects and product owners whenever you are trying to come up with a pipeline. When you are building a data pipeline, you need to check with them about latency and throughput. These are some of the critical terms that we need to talk to them whenever we are trying to ingest the data. This is only for data extraction. How we are bringing the data at that point of time, we need latency and throughput, guys. We need to understand those latency and throughput when we are trying to bring the data. So this is one of the question that you can ask your data architect whenever they are talking about pipeline building, that how how much of throughput you would need, how much of latency you would need, is should we bring the data quickly, or like that you need to check with them. Okay. Then we can start with batch processing. So batch processing, we have two types, batch and real-time processing of the data. So batch processing means processing data in a frequency, guys. Okay, so frequency is decided by your data architects. They are going to tell you how the data is going to come. Real time is processing data as it arrives. As it arrives means, let's say we have a storage location. Let's say we have a local desktop folder in our laptop and assume someone else is also using it. So what happens is, real-time processing means whenever a file is uploaded in this folder, immediately it is processed. Immediately it is picked up by our pipeline and it is going to apply some transformations. It is going to store the result into another folder. Let's say downloads folder in this case, right? So real-time processing means as soon as a file arrives in this location, it is picked up, it is processed, and it is going to be dumped in downloads folder. In a frequency means, let's say the same file is uploaded here, but our thing is, our requirement is, we have to process this file only after a certain frequency. Okay, let's say maybe there are so many files that are going to come, not just this one file, there are going to be 10 files. So once all the files are placed here, we are going to pick it up and process it and dump in download folder. And the second time we are going to process these files is after 1 month, or after one day, or after 10 days. Even if there are files uploaded in between this duration, we are not going to use them or process them. Okay, so a certain frequency is given to us, like month or day or week. Okay, depending on the frequency that is provided, we are going to process the files present in this folder. Okay, even if there is multiple files, there is new files uploaded in this frequency, still we are not going to work on those files, guys. That is batch processing. Real-time processing means as soon as a file is uploaded, we will not look at what file it is, I mean what frequency, we'll directly start processing. Okay. The advantage of real-time processing is latency, because if you recall, we discussed about latency. So latency is super low. That means, because you are processing the file as it arrives, right? It is coming and sitting here, you are processing it. So latency is super low. Latency is high. Okay, so latency is high. That means you are processing in a frequency, so it is going to be high. Throughput, it depends, but generally it is high. Throughput, again, it depends, but here it is moderate, not low, I would say. Then in the batch processing, guys, um, the advantage is, let's say you have large data, large volume of data. then it is recommended that you use batch processing, because only at that point of time you can define how you want to process this data. If you are going with real-time processing, you never you could not uh, process that data, because generally real-time processing is built for small amounts of data. In data engineering space, we call it as micro batches, micro batch of data. Okay, so let's say only small data is coming, only that data can be processed in real time. You cannot process so much of big data in real time, guys. Okay. Then if you want to give an example, in my organization, the organization where I'm working currently, what they do is they have something called monthly sales report, okay, or monthly payroll report. So they need this to be processed every month. So what they do is, even though there is data available, we are going to run this on a certain frequency. So this pipeline is going to be triggered only when we reach the end of the month, like 31st or 30th of the month, and we are going to present it on 1st of next month to the CFO and other people, right? So that is one example that we can think of. Real-time processing is, um, let's say if you are talking about Amazon, within Amazon, we are going to click on so many products, right? So as soon as you click on add to cart or place order, it is going to immediately trigger the order placing, and it is going to immediately trigger the payments and all. It is not going to wait. As soon as you click on save and proceed with the payment, it is going to do it, right? The um, other thing is about real-time processing and batch processing is cost, guys. So cost is much cheaper when compared to real-time. This is expensive. The reason this is expensive is it is going to need, I mean, this real-time processing needs a compute that is always running, guys, right? A compute that is always running, because you don't know when a file will be uploaded to this folder. It could be during night, it could be during day, it could be at any time. So you have to keep a compute always running to see as soon as it arrives, you have to process it. Here you can define compute and memory and other stuff depending on the requirements. You can turn off them for a month, and then you can just start it on whenever you require. So you have that flexibility, but here you don't have it. It is going to run continuously. So that is a most disadvantage of this real-time processing. So what happens in industry is sometimes they are going to merge this batch processing and real-time processing in the pipeline. Okay, so what they are going to do is, when they feel that data is going to be huge, they are going to pick this batch processing for that type of data. For real-time processing, they are going to pick easy or small amounts of data. So if we consider Amazon, so for batch processing, they are going to look at products, um, or sales or orders, something like this. So they are going to extract data from these tables in batch processing. For real-time processing, what they are going to do is batch time processing, real-time processing. Okay. So for real-time processing, what they are going to do is click events, cart related databases, order purchases. So all this click events are the most common thing that is processed in real time. So click events means whenever you click on a product, immediately the details of you who is clicking, the user ID, timestamp, what product you have clicked, are you a premium user? All this information is going to be stored in a log file, guys. Log file, we are going to talk about what it is, but all this information is going to be stored in this log file immediately. As soon as you click it, it is going to generate a record, and it is going to dump it in a log file, and this log file is given to machine learning team and the other teams, so that it is visible when you open the Amazon again, like most last recently viewed products, right? So those things will be done. And also it is going to help them to give you a personalized discount. Okay, so that's about batch processing and real-time processing. So the like I said, there are certain architectures in our cloud space. So we call it as Lambda architecture. Okay, we call it as Kappa architecture. So these are some of the architectures, medallion architecture. We are going to talk about all of this as we progress in future, but this is just to give you a quick overview. So these architectures define how you want to process the data, whether in batch or real time. Like in medallion architecture, it is going to be batch. In Kappa architecture, it is going to be batch plus real, like this. Okay, so Lambda is going to have batch plus real again. Lambda is a bit older version and Kappa is a bit latest version. Okay, so there are certain architectures that are going to define how we want to process the data. And we are going to talk about this in much detail when we move to processing the data in Databricks. Okay. Yeah, Deepak.
Which architecture is currently used in the industry, like which is the most famous that is being used in the industry right now?
Right now, they are actually going with Medallion if you are using Databricks, and also they are going with Lambda architecture. Okay, so like I said, if you need real-time processing for sure, then they are looking at Lambda architecture. If you don't need real-time processing at all, then they are simply going with Medallion architecture. So Medallion architecture we are going to discuss, and we are also going to be looking at how we can read batch data in real time. Okay, so that this is going to be uh, uh, a future concept that you are going to discuss, but we can read the batch data in streams. Okay, this is a beautiful concept that was implemented by Databricks and Spark. So we are going to touch base on this in our future classes, that how you can do batch processing in streams. Okay, it is going to be a good topic to discuss, but for now, I think this is enough for our introduction. Then we will continue with the pipelines real quick, and then I'll start with orchestration, and then we'll finish it off for today. So pipelines, guys, it is nothing but a sequence of steps. All right. So sequence of steps means you have some activities that you want to do. Like for example, let's say extract data from Azure, not Azure. Let's say some your local desktop. Okay. Then store it in Azure. Then process it using Spark. Okay. And then store it in a data warehouse, let's say. Okay. These are some of the sequence of steps that you want to do. Now, what you will do is, instead of doing this individually, you will collectively build a system that is going to consider this as a step 1 and step 2 and step 3 and step 4. Okay. So you will define each of these as a steps to a process, to a tool, to a software, and then that software is going to execute this all of these steps in sequence. Okay. So whenever you are going to trigger this sequence of steps, which we call it as a pipeline, it is going to run all these 4 steps. Okay, you need to define when you want to run this. Okay, so the pipeline is nothing but a sequence of steps. The other point is pipelines could be batch pipelines or real-time pipelines, guys. Okay, so you can even in your real-time processing, you can define the same steps in real time also, right? You can, extract data and process it. You can do this in real time also. So pipelines could be batch processing pipelines or real time processing pipelines. Um, Generally, we use pipelines in Spark, Data Factory. Within Databricks, we have Databricks workflows, which we are going to cover. It is in scope. All these are in scope. So we use these three to build pipelines, guys. Data Factory is most preferred, and Databricks Workflows is the second most preferred while building the pipelines. Okay. We'll start with orchestration because these both go hand in hand, guys. Orchestration and pipelines. So orchestration is nothing but, let's say your pipeline is ready, right? But how do you want to trigger it? So let's assume in a MNC, the files are going to come at odd times. Maybe it could be a night for you if you are working in India. Somewhere around 3 a.m. or 4 a.m. in the night, you are going to receive the files. So at that time, nobody is available to trigger this pipeline, right? So orchestration solves that problem by automating the pipeline execution. So what you are going to do is you are going to define a condition. It's need not to be condition always, but for now, let's define a condition that whenever a file is uploaded in this folder, I want to run this pipeline. Okay, I want to extract the data, I want to store it in Azure, I want to process it and then store it in a data warehouse. So that is my condition. I'll say I'll give it a folder, whatever tool I'm using, whatever software I'm using for orchestration, I'm going to give it a condition. I'm going to give the folder path. Okay, let's say the folder path is desktop/sales. So whenever a file is uploaded in this sales folder, it is going to trigger the pipeline. That's it. So here you need to remember one thing, that we are just triggering the pipeline. The resources are allocated dynamically, right? To process this data in Spark, we need compute, we need memory. To store in data warehouse, we need to define which warehouse we have to load. That warehouse should be running. If it is in cloud, it should be running, right? If it is in Azure, then where in Azure? How are we going to access? All of this is going to be covered in future sessions. This is just for an overview that um, let's assume that all of those are covered and all of the resources are available. So this is how we will orchestrate. We are going to define when a pipeline should be triggered and we are going to automate it based on a condition. Okay. And this condition is given to us by data architects. So they are going to tell you run this pipeline is at this time. Okay. So based on that, we are going to run. Okay. Even in process it using Spark step, we will have multiple steps, like reading the file, applying transformations, cleaning it, and then we will store it in data warehouse. So the pipeline is going to be big and it is going to involve so many steps. So this is just a small overview of the pipelines and orchestration. Some of the examples for orchestration would be Apache Airflow. This is widely used if you are not using cloud. If you are using Azure cloud, then it is again Data Factory. So Data Factory solves this pipeline building and orchestration both within the uh, single service. Then we have Databricks, same Databricks workflows. So workflows is also like Data Factory. What it does is it is going to give you option of building pipelines and orchestrating. Orchestrating means scheduling the pipeline based on some of the triggers that you want to uh, define. Okay, so these are some of the data concepts, guys. I'm sure we are already done with this time, but I wanted to touch base on structured, semi-structured, and unstructured as well. Tomorrow, not tomorrow. Do you guys have some more time, like another 5 minutes or 10 minutes? Can we extend this?
Yeah, sure.
Okay, so let's also start with structured. Mhm. Is anyone speaking? Okay. So, as you all know, structured data is nothing but a data that is clean. Clean as in it has a predefined schema. Schema means columns or header. So we already know what columns we are reading. We already know what data types it is going to have. Okay, we already know whether it is null based, it has nulls or not. Yeah, Sangi, no problem. Okay, it has nulls or not. Then generally structured data is stored in tables, guys. Okay, tables or spreadsheets. We are going to talk about that. Okay, but the idea is that you know schema. Okay, so what it means that it is schema on write. So schema on write means whenever you are writing data to a file or a table, you should have defined the schema. Schema means columns, data types, and whether it has nulls or not. If you don't define these three, you cannot write that data into a structured format. So that is the expectation. It is schema on write. Okay. Generally, this data can be queried using SQL. Okay, even if it is spreadsheet, we can still load it into a database and then we can query it. Generally, this structured data is used in transactional systems, which we call it as OLTP. Okay, so some of the examples are your CSV, your Excel, your SQL tables, and there are few big data file systems called file formats called Parquet, Avro, and ORC. We are going to talk about these last three items in detail tomorrow. I mean, in our next class. Okay, but transactional systems means anything that is getting updated more frequently. A database that is getting updated more frequently. More frequently means it could be as soon as a transaction is completed in real time sometimes. Okay. So this is getting updated more frequently, and this is also going to store only the latest or current information. We are going to talk about this OLTP, OLAP, and all of that in our next class. But for now, just consider that OLTP systems or transactional systems are those systems that get updates more frequently, and that is going to store only latest or current information. Okay, it is not going to store any historical information, right? So this is structured data, and we will see how Parquet, Avro, and ORC are structured formats in upcoming sessions, because in our future session we have a detailed discussion on these file formats, all of these file formats. Okay, so semi-structured means it has some level of hierarchy or a schema, which means it's not fully structured, it's partially structured. Okay, best example would be JSON or XML, or there is a new term called YAML. This is widely used in CI/CD pipelines, okay, in Azure DevOps. So let's say you are storing employee information. Okay, you can just write it like this. So for some of the employees, you may find name. Okay, may find name or one, then address as Hyderabad. Okay. Then for second employee, you may have different columns. You may have name as Raghu and the address as XYZ, but he might also have a phone number like 1234. All right. So this could be one of the examples for JSON where you might have a different column names, but you understand that it is all belongs to an employee information. Okay. So similarly, it will have some structure, but it is not completely structured. Generally, this is used for APIs or IoT data or log files. We discussed about log files before, right? So all those log files, majority of the log files are going to be either text format or JSON format. So if you click on any product in Amazon, automatically a text file or a JSON file will be generated, or already generated JSON file is going to be updated with your record. Okay. So generally, if you do API calls like GET request, POST request, if you use REST APIs, the standard default format is JSON format, right? So it is widely used in API. And if you want to process this data, we can always uh, do it using Spark. In Spark, there are options to read JSON data, XML data, or the log files. So we can also work on it as a sample when we are doing it, and we will see how it is being processed. Okay. So that is semi-structured, guys. Unstructured data is simple. There is no schema. No schema means there is no rules on schema, which means it becomes schema on read. Schema on read means while reading the file, you are trying to understand what are the columns, okay? What are the data types and whether it has nulls or not. You don't know. You don't know before reading the files. You will get to know after reading the files. That is the schema on read. That is the schema on write. Okay. This is the main important point that we need to remember while differentiating between structured and unstructured. So this is generally hosted in data lakes. We'll talk about data lakes in detail in our next class, but data lakes is nothing but a storage system, a cheap storage system, which is dead cheap. So that's the reason people store unstructured data in data lakes. Structured data, because it is transactional systems, it could be in databases, data warehouses. It could also be in data warehouse, database, data marts. Then there is data.
So in general, like what type of data the companies will receive, unstructured data?
Yes, so they are going to store it in data lakes first. And what they are going to do is they are going to do something called ELT. We'll talk about ELT and ETL. What they're
No,
going to do,
I'm asking like from where they get these, like suppose if it is structured or unstructured, so through the applications they will receive that one, either database tables or
yes,
applications or something.
yes.
From where they will get the unstructured data?
Okay, good question. I'll give you one example. So what happens is
Mhm,
that I believe you heard about MongoDB. So MongoDB is one of the
mhm.
unstructured database. Okay, we
Okay.
call it as NoSQL databases. Which
Mhm,
means with NoSQL databases are generally used for unstructured data. Okay, so what happens is when we log into a system or any application,
mhm, mhm.
automatically the login information is going to be stored in MongoDBs in general. Okay,
Okay.
even in our industry, they are using MongoDB to store the login information. So that is how the data is going to be generated.
Okay.
Okay,
Gotcha.
so that's how
Mhm,
they are going to use this, and sometimes it depends again. In my organization, what they do is we have some PDFs. We have some PDFs to process. So in some of our projects, we have seen clients who store their payroll information in PDFs. Okay, so they have some standard reports in their system, and the standard reports output is always PDF. Okay, so this is also an example of unstructured data. So what happens is their entire employee information is coming out of a report, and that report is PDF. So we need to think about how to convert this PDF into usable format like Parquet or CSV or Excel, and then we need to prepare a solution, and then that's how we process. This is rare. This is rare. This doesn't happen every time, but this is a opportunity or a possibility. It could come up. And I mean, it will not be in big data also sometimes, but this is also something that we need to take care while we are working on data engineering pipelines. Okay. And the disadvantage is it is not easily readable or queryable. I mean, you cannot directly open that file, read it, and then query it. Okay, because it is predefined. And the other challenge is it may come in various formats. So you don't know if you are going to get a MongoDB file, or you are going to get a PDF file, or you are going to get a text file, right? So it may come in multiple formats. The unstructured data example is text files, PDFs, sometimes images, and sometimes NoSQL or uh, outputs, right? It could be document, it could be anything.
I got a quick question. So are audio or video files ever part of this unstructured data for data engineering, or they're typically not included in unstructured because they are unstructured data, but I'm just curious, like, are they typically processed for any kind of data engineering projects? Have you ever seen them being
Yes, yes. Actually,
okay.
one of my projects, I just told you, right, that I had a requirement of looking at PDFs because the client with whom I am working with, what they have done is they have sent me some standard reports from their system. Okay,
Oh, no,
they
I was
that
asking about
huh?
audio and video files. Like,
Audio and video files,
yeah,
no.
no, okay,
Yeah, we
okay,
didn't get that. We didn't see it at all. In my experience,
okay.
I have never worked on audio and video. It was always either text files because log files are text files sometimes, or a PDF. PDF happened. I mean, it is also rare. It happened
Mhm.
with only one of my projects, but majority of the unstructured data will come in text files.
Okay.
Yeah,
Emails could be one, right?
yeah,
Emails could
yeah.
be,
Emails
yeah.
could be one. Correct.
Okay. Yeah. Thank you.
Okay. The other challenge is that you cannot use it, guys. You cannot, it's not usable. You need to pre-process the data before you use it. Okay, so that's a disadvantage. And another disadvantage is that you need to store this data first before processing. Okay, so that means that because you are storing the data first, it is going to incur some storage cost, right? If it depends on the storage methodology you are using, but still you have to store it first and then you have to use that storage system. So it is going to throw some additional cost on the storage. So these are some of the disadvantages of looking at unstructured data. And for structured data, yeah, if you go with the ETL concepts, which means you are going to transform the data immediately after extraction, you are going to use a staging layer, but it's not going to be as expensive as storing unstructured data, because unstructured data is like storing everything. You will not store only what you need, you will store everything that is going to come. So unstructured data is going to take more cost in terms of storing the data, but we have options to store the data in a cheaper way, which is why currently industry is focusing on ELT instead of ETL. Okay, so they are more focused into ELT. They want to load the data because they have a cheaper options today, like data lakes, data lake houses. All of these are some of the cheaper options that they can look at. So ELT is more, you know, I think it is the future, I would say. ELT is like that. ETL is still an option, but there is less scope going forward for ETL. Okay. That concludes our day three, guys. Just a reminder that if you like this content, if you feel like you need to continue with this content, please reach out to Isha admin team, and they are going to help you with all of the registration, course registration, and the payment options. And we can continue this discussion on Monday. So Monday it is going to be fun because we are going to talk about data lakes, databases, data warehouses, and data lakehouse in detail. We are going to touch base on all of these file formats. What is CSV? What is Parquet? How Parquet is used in big data? Why it is super critical to use Parquet? What is Avro? Avro's advantages? What is ORC? ORC advantages and all of that. So it is. I don't want you to miss that session. It is going to be super fun. Then we'll get started with data fundamentals. When I say data fundamentals, like databases and all. So then we'll kick off with our Azure fundamentals immediately. I think it will be on Tuesday, somewhere around Tuesday. We'll start with Azure fundamentals, and we'll see from there. We'll try to start Azure storage account as our first Azure topic. So please feel free to ask any questions you may have
Just a
after.
quick question I have. So I have a quick question. You mentioned like that some of us might know pandas. I actually don't know pandas. So I'm just curious that is that a hard requirement, or you could actually cover like the amount of pandas that is needed?
Yeah, so we have a dedicated Pandas session in this course itself. It is
Oh,
going to
okay.
come at week 3. So when we are actually going to get started with working on data, before that week, we are going to have a session on SQL and Pandas. So SQL will be covered in depth. Pandas will be covered in basics because we are not going to use pandas. Pandas is just for your information or just for your understanding, because to learn PySpark, it is good if you understand pandas first. Okay, so
Okay.
that's why
Yeah.
we have a dedicated session on pandas. We will touch base on basic concepts of pandas and how data is processed in pandas, along with some SQL topics.
Okay. Mhm.
Okay, so that is part of this course that is in scope. So thank you. Any other
Thank you.
questions, if you have, feel free to post those questions in the chat or to me. We can, continue the discussion in the groups as well where we are part of. So let me stop this recording.